morning, class. Allow me to introduce myself first. I am Kim Luigi C. Talbas. And this morning, we're going to talk about Eulers Phi Function. First, we need to define what is Eulers Phi Function. So, Eulers Phi Function is for every positive integer, a and n, which are said to be relatively prime to n. And it is denoted as phi, the quantity of n, or phi of n. And phi of n is the number of positive integers less than n that are relatively prime to n. So let's have an example for us to understand. So find phi 5. So our n here is 5. So the first step we need to do is to list all the elements. So the elements are 1, 2, 3, and 4. And the next step we need to do is to check or to find the GCD if their GCD are relatively prime to 5. So first, 1 and 5, the GCD is 1, and 2 and 5 is also 1, and 3 and 5 is also 1, and 4 and 5 is also 1. So therefore, there are 4 numbers that are less than 5 and relatively prime to 5. And in Euler's Phi function, there are 3 cases. So the first case is when n is prime, so we can use the formula phi of n is equal to the quantity of n minus 1. And the case 2 is if n is equal to p times q, p and q are prime. So we can use phi of n is equal to the quantity of p minus 1 times the quantity of q minus 1. And the third case is when n is equal to a times b, either a or b is composite. So we can use the formula phi of n is equal to n times the quantity of 1 minus 1 over p sub 1 times the quantity of 1 minus 1 over p sub 2, and so on and so forth. And where p sub 1 and p sub 2 and so on and so forth are distinct prime. So for us to understand these 3 cases, so let's have an example. So our first example here is find phi of 5. So our n here is equal to 5. So this example, we can use case 1. So in the case 1, the formula is n minus 1. So our n here is 5. So we need to substitute the given to the formula. So n minus 1 is equal to 5 minus 1. So if we subtract 5 minus 1, the result will be 4. So therefore, there are 4 numbers that are less than 5 and relatively prime to 5. So let's have another example. Find phi 31. So our n here is 31. So since 31 is a prime number, we can use this example case 1 also. We substitute r given to the formula. So n minus 1, our n is 31. So now we have 31 minus 1. And if we subtract 31 minus 1, the result will be 30. So therefore, phi 31, there are 30 numbers that are less than 31 and relatively prime to 31. And now let's proceed to our another example. So in our third example, find phi 35. So in this example class, we can use the second case, where we use the formula P minus 1 times the quantity of Q minus 1. So 35. So the first step we need to do is to find, or we need to factor out using prime factorization. And if we factor 35, the answer will be 5 and 7. And 5 and 7 are prime numbers. So our P here is 5 and our Q here is 7. And now we substitute them to the formula. So our formula is P minus the quantity of P minus 1 times the quantity of Q minus 1. So our P is 5. So 5, the quantity of 5 minus 1 times 7 minus 1. Then we subtract 5 minus 1, 4, and 7 minus 1 is 6. And now we have P of 31 is equal to the quantity of 4 times the quantity of 6. And if we multiply 4 and 6, the result will be 24. So therefore, there are 24 numbers that are less than 35 and relatively prime to 35. And now let's proceed to our fourth example. So our n here is 1,000 because we will find to phi of 1,000. So this example class, we can use the third case. So according to third case, we can use the formula phi of n is equal to n times the quantity of 1 minus 1 over p sub 1 times the quantity of 1 minus 1 over p sub 2, and so on and so forth. And first thing we need to do is to factor out 1,000. So the result will be 2 cubed times 5 cubed. So our p sub 1 here is 2 and our p sub 2 is 3. So now let's substitute them to the formula. So phi of 1,000 is equal to 1,000 times 1 minus 1/2, where 1/2 is our, and times the quantity of 1 minus 1/5. And if we subtract 1 minus 1/2, the result will be 1/2, and 1 minus 1/5 is 4/5. So phi 1,000 is equal to 1,000 times the quantity of 1/2 times 4/5. So if we calculate this one, the result will be 400. So therefore, there are 400 numbers that are relatively prime to 1,000. And now let's proceed to our last example. So our last example is find phi of 7,000. So our n here is 7,000. So this example class, we can use the third case. So in the third case, the formula is phi sub n is equal to n times the quantity of 1 minus 1 over p sub 1 times the quantity of 1 minus 1p over sub 2, and so on and so forth. So the first thing we need to do is to find the factor, or we can use the prime factorization. So the result will be 2 cubed times 5 cubed times 7 over 1, raised to the power of 1. And now our p sub 1 here is 2 and our p sub 2 is 5 and our p sub 3 is 7. So now let's substitute them to the formula. So phi 7,000 is equal to 7,000 times the quantity of 1 minus 1/2 times the quantity of 1 minus 1/5 times the quantity of 1 minus 1/7. And if we subtract 1 minus 1/2, the result will be 1/2, and 1 minus 1/5 is 4/5, and 1 minus 1 over 7 is 6/7. And then we need to multiply 7,000 times 1/2 times 4/5 times 6/7, and the result will be 2,400. So therefore, there are 2,400 numbers that are relatively prime to 7,000. And that's all our discussion this morning. Thank you for listening, and goodbye.